All right, we have a couple examples here, and I noticed it wasn't split up very well. So the red heading is separates examples. Okay. A couple more probability type questions. I'm going to show them in somewhat different ways, but uh, sometimes I think more examples is easiest to see and learn from. So that's what I'm going to do. So this first one, we have 8% of a certain batch of calculators have a defective case, 11% have defective batteries, 3% have defective case and batteries. We select a calculator at random, find the probability that a calculator has a good case and good batteries. All right, kind of a lot going on. I'm going to write this union rule really quick for probability. We could use this, but I'm going to show kind of a different approach in this one, especially because the last video I caught it before I finished, but I'd actually wrote this formula wrong. Right here, I wrote a union again, and that wouldn't have made any sense to call that a union. Anyways, so this union rule says if I'm counting probabilities, I need to add the probability of each, but take away the intersection because I would double count it, right? This intersection means it was part of E and F. So if I count that probability here and I count it here, I have to take away any double counts, right? That's one approach. I'm going to show what that looks like in a Venn diagram for this one. All right, so we have this batch of calculators, right? And I'll just do green here. 8% have a defective case. I'm not drawing to scale. I'm just showing there are some batteries that have a defective case, okay? And then we have some that have defective batteries. And then we have some that are defective in both ways, and that was 3%. All right, so 3% have both. 8% have a defective case. Well, if the 8% counts as 3%, then that leaves this 5% that have a defective case alone, right? But then a total of 8% have a defective case because the 3% is counted for the batteries. They have defective case and batteries. Likewise, 11% have defective batteries. So that leaves 8% that have a defective battery but not a defective case, right? The sum of the red is 11%. The sum of the green that I have total is the 8%. This matches exactly what the question reads. So without any formulas, you could kind of see what's going on there. You could see how much belongs to it. And then we have the entire set, and the ones that don't have any defection, well, we have 100% minus that 5, minus that 3, minus the 8, right? 100% minus 5 plus 3 plus 8%. And so that would yield 16 in here. 100 minus 16 is 84%. So outside, we have 84% that are not defective at all. Okay, I didn't particularly use any formulas to solve this problem. They're asking the probability it has a good case and good batteries. 84% good case and good battery. Okay, if we didn't draw a Venn diagram and use the rule, which nothing wrong with that, the probability that it has a good P of E, right? We'll say P of E, or we'll say P of C. Probability has a good case. Well, if 8% do not, right, 8% are defective, then 92% do have a good case. How much have a good, maybe it might be easier to actually do this. Yeah, I think so. Let's go ahead and stick with we'll do the complement at the end. Probability of a bad case, 8%. Probability bad batteries, so we'll just call it P of B, bad batteries, we knew was 11%. Minus the probability of bad case and, right, intersection and bad battery, 3%, would lead to 16% that, let me give myself a little bit of room here, 16% have a bad case or bad battery union, right? So I want a good case, so that would be the complement of this. So to do the complement, we just need 1 minus this, and 1 minus 16% is 84%. Alrighty, moving forward. I know that was a few different ways, but we all kind of see it differently, and maybe you want a formula, maybe Venn diagrams works, maybe you didn't need any of it, you just kind of saw it. The probability that a company will make profit this year is 0.74. Find the probability that the company will not make a profit. All right, well, that's pretty straightforward, right? If it's 0.74, the probability that they do make profit, probability they make a profit, we'll just call that P, plus the probability they do not make a profit, complement, right? Always sum to 1. So if I know that the probability they do make a profit is 0.74, then to solve for, the probability that they do not make a profit, I need to subtract that on both sides. .26 or 26%. Okay, probably leave it at 0.26 since that's the way it started. Find the odds against the company making a profit. Okay, so the odds against them making a profit is like saying P prime to P, right? I need this to this. And if this is 0.26, then 0.74, as we were told, right? That's the probability they do make a profit. So the odds against them making a profit, not making a profit, to the odds they do make a profit. And reduce, I see they both divide by 2, and I think that's it. And typically, like, we can also multiply both sides by 100. There's no point of having a decimal. So really this is equivalent to just saying 26 to 74. But then again, we need to reduce, right? Divide by 2, 13 to 37, and those are both prime. All right, pretty straightforward problem there. This last one. Now we have this chart, and it's a survey with these different percentages of how long people answered that they would wait for a page to load. All right, so less than a second, they are impatient, 3%. Right, 1 to 5 seconds, 16, and then it goes on from there. Find the probability that a person would wait the following amounts, no more than 10. Okay, we could break these down with formulas, but I think in these ones, it's much easier. Let's look at the chart and see which probabilities meet the description. There is no intersection. These are all discrete, right? Like they're not double counted. Anyone not wanting to wait no more than 10 seconds would be up to here. Okay, no more than 10. So up to 10. 10 is my limit. Once I reach 11, I'm done. And if we look at those percentages, 3 plus 16 plus 30, we get 49%. Okay. At least 6 seconds. Okay, at least 6. So anything 6 or greater. So the sum of all those, 30 and 16 and 15 and 20 is 50, 71, no, 81, right? 50, 67, 81%. Okay. between 6 and 20 inclusive. Between 6 and 20 inclusive would be those. 30 and 16 and 15 is 61%. You could pause and add that up if you need to see it. And between 1 and 15 inclusive. So between 1 and 15, so we're not counting less than 1. Okay. So that would be 62%. 16 and 30 and 60, 62%, or 0.62, depending how they want the answer. Typically, my suggestion, if it's listed as a percent, your answer should be listed as a percent. If it's listed as decimals, like here, then your answer should probably be decimals as there.